Hello, in this video we're going to take a look at some examples of graphing using transformations. So for this first one we're going to describe the graph, we're going to graph the function, we're going to show all the steps graphing that function, we're going to make sure and track our important points, and then identify the domain and range at the end. Alright, so our equation is f of x equals -2 times x plus 3 cubed minus 4. So here I do see that our first thing we want to look for is figure out what our parent graph is. And our parent graph in this case has a cube in there, so that's going to be the function y equal x cubed. Actually, let me do this on the other side. And then you can just work left to right. So this negative out front, that's on the outside of the function, so that means it's going to be a vertical change. It's going to be a vertical reflection. Vertical reflection, remember, is like looking at the reflection of a tree in a pond. The 2 out front here is going to be, it's multiplied, so it's going to be a vertical. It's on the outside, so it's a vertical. It's multiplied, so it's going to be a vertical stretch by a factor of 2. The plus 3 on the inside, it's on the inside of the function, so that means it's going to be a horizontal change. And it is going to be a horizontal shift. And since that's a positive number, remember anything on the inside is the opposite of what we expect. We're going to go to the left 3. And then our last step is going to deal with that minus 4. It is on the outside, so it's going to be a vertical change. And a plus or minus is going to be a vertical shift. In this case, we're going to go down 4. And I like to color code this. I'm going to do my parent function here in black and then the other 4 graphs in the colors that they have. So that's describing. So now let's graph it. Our cubic function normally goes through the point at the origin at 0, 0, the point at 1, 1, and the point at -1, 1. And it looks like a parabola that you have twisted like a paper clip. Alright, so I'm going to go ahead and write my points 0, 0, 1, 1, and -1, -1. We'll kind of track as we go. Alright, a vertical reflection means we're going to reflect it vertically. This point here at the origin is going to stay at the origin. The point here at +1, 1 is going to flip across the x-axis, and that point is going to go to 1, -1. It is a vertical change, so only the y value will change. And then for our last point, it's going to flip across the x-axis as well and move to the point -1, +1. And we're going to get that same picture reflected across the x-axis. Alright, our 2 is a vertical stretch by 2. That means we're going to multiply our y values by 2. So this point at the origin has a y value of 0. When we multiply it by 2, it still is going to have a y value of 0. Now we're looking at these red points here. And so this point here that is at 1, -1, when we multiply that y value by 2, it is going to move to a y value of -2. And then our last one, again, this is a vertical change. All of these transformations we've done so far have been vertical changes, so our x values are not changing, only the y values change. We're going to multiply our y values by 2, and our graph is going to be twice as tall. The only So it's going to be twice as tall, but our x values will stay the same. All right, our next transformation is this horizontal shift. This is going to be an x horizontal change, so it is going to change our x value. We are going to go to the left 3, so this point here at the origin is going to move 1, 2, 3 units to the left and move to the point -3, 0. Notice our y value didn't change on that step, only the x value did. Same thing's going to happen when we move each of our other 2 blue points. Our x value is going to move to the left 3, and the y value is going to stay the same. And graphing with my pen here where I can't see as well. This is not the ideal solution. All right, notice how that green curve is going to look just like our blue curve, but shifted to the left 3. And our last transformation here is we're going to go down 4. This is a vertical change, so only our y values are going to change. We're going to go down 4 on each of those. So that point that originally started at the origin is now at the point -3, and it's going to go down 4, so -3, -4. And then the point that originally started at 1, 1, that's this point here on the right-hand side of our green graph, is going to go down 4 from there. So that's going to be at a y value of -6. And then our last one starts at a y value of 2, going down 4 is going to move it to -2. But our x values are going to stay the same. And so our final graph there is going to be the gray graph, the one that is that green one shifted down 4. We've tracked our points, we've shown all of our steps. Now we need to identify our domain and range of the final graph. And this graph is going to continue to get wider and wider and wider as it goes across. So our domain for that one is going to be -infinity to infinity. And then it will continue to go up forever and down forever. Our range is also -infinity to infinity. All right, now let's look at some that are a little bit smaller. But instead of using one of those standard parent graphs, on this one, we are given our parent graph. So this little almost trapezoid, we've got 3 of the 4 sides for a trapezoid, that we're going to use this as our parent graph. And so I've just copied and pasted that. If we wanted to graph, if that is our f of x, if we wanted to graph f of x plus 3, what that means we are doing is we are going to go up 3. That 3 is on the outside, so it's a vertical change. When we add or subtract, each of those go up 3. So up 1, 2, 3, and up 1, 2, 3, up 1, 2, 3, and up 1, 2, 3. And so our final graph here is that same shape, just shifted up 3. If we have that plus 3 on the inside of our graph, or inside of our function, inside of the parentheses here, that means it's going to be a horizontal change, and it's going to go the opposite of what we normally expect. So in this case, it is going to go to the left 3. So we're going to do the same thing and just move each of those points to the left. 1, 2, 3, 1, 2, 3, and 1, 2, 3, which gives us that exact same shape We're just shifting it over to the left. All right, a 1/2 out front means that we are going to have a vertical change. It's on the outside of our function, and we're going to multiply all of our y values by 1/2 because it's going to be a vertical compression. And so it's going to take all of our y values here and multiply them by that number out front, 1/2. So -2 times 1/2, our x value is going to stay the same, so we're going to have the same x value, still going to be at -4, but it's going to move to a -1 y value. And this one has a y value of 2, so it's going to give us a y value of 1. Same thing's going to happen for this one on the y-axis and for this one on the right. And so what we get is a graph that has the same shape, but it is now half the height. It's been squished into the y-axis by a factor of 2. All right, if we have a 2 on the inside of the function, remember it does the opposite. Instead of multiplying by 2, we're going to divide by 2 on our x value, because this is going to be a horizontal compression. So now we're looking at our x coordinates, the -4, -2, 0, and 4, and we are going to divide those x values by our coefficient of 2. So -4 is going to become a -2. Our y value is not going to change, only our horizontal or our x component. -2 divided by 2 is going to give us -1. 0 divided by 2 is still going to be 0. And 4 divided by by 2, is going to be 2. So now we get the compression going the other direction. And we get the same basic shape, it's just squished in towards that y-axis. All right, our last two examples here, we're looking at reflections. A negative on the inside means it's going to be a horizontal reflection. So that is going to be where we're reflecting across something across the one side of the horizon to the other. So across our y-axis, instead of being at a -4, it's going to change that x coordinate to a +4. So it's going to move right on top of where this one is. And that one's going to move right on top of where this one is. This one at -2, 2 is going to move over to a +2, 2. And then the point at 0 is going to stay the same. And so what we see, instead of having that longer leg on the right, like our original, we have that longer leg on the left. If we have that negative out front, it's going to be a vertical reflection. And that's where we're going to reflect it like we see in a pond. We're going vertical is only going to change those y values. So our y value is going to change from a -2 is going to move up here to a +2. This one at +2 is going to go down to -2. Same thing for that one on the axis. And then our point over here on the right is going to flip over. So now instead of it looking like a little slide, now it looks like a bowl. All right, I will see you guys next time.